Welcome to a lesson on parameterized surfaces. We've already looked at how to parameterize a plane curve or a space curve using the parameter t, as we see here for a plane curve and here for a space curve. But to parameterize a surface, we will need two parameters and three independent variables. So our parameters will be u and v, and the dependent variables will be x, y, and z. So x, y, and z depend on u and v. And our two parameters u and v define a region R in the UV plane where the vector R of UV will sweep out the surface. So let's take a look at some examples of how to parameterize a surface. Here we have the plane 2x minus 3y plus z is equal to 6. So if we let x equal u and y equal v, we could solve this equation for z and then replace x and y with u and v. So let's go ahead and do that. So we would have z would be equal to 6 minus 2x plus 3y, which in terms of u and v would be 6 minus 2u plus 3v. So we can now write the surface as a vectored valued function in terms of u and v, where the x component would be u, the y component would be v, and the z component in terms of u and v would be 6 minus 2u plus 3v. Well, that one was pretty straightforward. Let's go and take a look at a couple more examples. For our second example, we have x squared plus the quantity y minus 2 squared is equal to 4. We can see from the graph that it's a cylinder. So to parameterize this surface, we're going to take advantage of a trig identity. Remember that cosine squared theta plus sine squared theta is equal to 1. So what we're going to do is set this equation equal to 1. So we'll divide everything by 4. That'll give us x squared over 4 plus the quantity y minus 2 squared over 4 is equal to 1. So now if we let x equal 2 cosine u, again we want to use u and v, and then y minus 2 equal 2 sine u, it would satisfy the given equation. Let's go ahead and solve this equation for y. So we have y equals 2 sine u plus 2. And notice there's no v in this equation because this surface is not bounded vertically. So we can just let z equal v, and we've now parameterized the surface. The vector valued function would be equal to 2 cosine u, 2 sine u plus 2, and v. Let's take a look at one more type. Here we have a sphere, x squared plus y squared plus z squared is equal to 9. So we'll use spherical coordinates to parameterize this surface. Since our radius is equal to 3, we know that rho is equal to 3. So we can go straight to the parameterization. We'll just let u equal phi and v equal theta. So we'll have 3 sine u cosine v (3 sine u sine v) and the z component would be 3 cosine u. Now let's take a look at a couple problems where we're given the parameterization and we want to determine the rectangular equation. So here we know that x would be equal to u, y would be equal to v, and z would have to be equal to the square root of u squared plus v squared. So again, this first one here is pretty straightforward. We could just perform a substitution because we know that u is equal to x, so we'd have the square root of x squared, and v is equal to y, so v squared would be y squared. And now we have the equation in rectangular form. Let's take a look at another one that's a little bit more involved. So from this parameterization, we know that x is equal to 3u sine v y would be equal to 3u cosine v, and z would be equal to u squared. So here we're going to use another trig identity. If we solve these first two for sine v and cosine v, we can then use the identity that cosine squared v plus sine squared v must equal 1. Solving this equation for sine v, we'd have x over 3u equals sine v. And here we'd have cosine v equals y over 3u. And we'll leave this equation as z equals u squared. So again, since we know that sine squared v plus cosine squared v is equal to 1, it must also be true that x over 3u squared plus y over 3u squared must equal 1. Well, this is going to give us x squared over 9u squared plus y squared over 9u squared is equal to 1. Now let's go ahead and multiply everything by 9u squared. So that'll give us x squared plus y squared equals 9u squared. But guess what? U squared is equal to z. So we know that x squared plus y squared must equal z. And we have our rectangular equation for the given parameterization. I hope you found these examples helpful. Thank you for watching.